So you have just started learning Verilog and learning digital circuit design, or maybe you already know how to use Verilog, but you think that you need to edit Verilog code everywhere. So in this video, I'm going to show you how to use Icarus Verilog, which is a Verilog compiler in any Android device. Okay, I'll do it in a tablet. This is a virtual tablet actually, but you can do the same in any Android tablet or mobile phone. The software we are going to use is called Termux. Okay, so Termux is like a Linux distribution inside Android. Sometimes some people think it's a terminal emulator, but it's much more than that because Termux has a terminal. It's the way to access the software you install with Termux. But the difference with other terminal emulators is that you don't run the software installed in your Android device, but the software that is installed by Termux itself. And they have lots of standard Linux packages with Termux. So if you already know how to use the Linux and the Linux command line, then you will feel comfortable with Termux. If you have never used the Linux command line, then Termux is a good way to get introduced, so you can check and see if it's for you or not. You can install Termux from the Google Play Store, or you can also install Termux from f-droid, which is an alternate store for free software. I don't want to configure the Play Store here in the device, so I will better go to f-droid. First, I'm going to install f-droid. Okay, you can install f-droid right from the f-droid webpage. You download the APK, and now let's open the package. Okay, now the system, I'm trying to install that from inside the web browser. So first I have to give permissions to the browser to install applications. You don't really need to do all that if you have a regular Android device, because you can go to the Google Play Store and that could be done. Okay, now that we have our marketplace here in f-droid, let's leave it like that. We can enter f-droid and install software from there. Actually, f-droid is very interesting because it only includes free software. So these are packages for doing lots of things, but they don't typically include any publicity. They don't try to spy you. They don't need more permissions than necessary. So anytime I need some new application, I always try f-droid first. They have software to do many common things like calculators, lanterns, and everything. So we are looking for Termux, as we will do in the Play Store, and here, terminal emulator with packages. And now we install Termux. Okay, now it's downloaded now. We have to allow f-droid to install applications, because this is the first time we install it. Okay, you see Termux doesn't need any special permissions. And here we go. Okay, we'll take Termux from our, this is already installed. So let's open it, and here you are. Okay, you have a terminal from where you can execute commands. I'll put this a little bit bigger. Okay, now if you are familiar with the Linux terminal, then that's it. Okay, you have a small Linux system. The good thing is that you can install packages as well. The Termux use a package manager which is called PKG, but actually it's a front end to the very popular APT package manager that includes major distributions like Debian or Ubuntu. So you can use APT if you are used to Ubuntu as well, or it's more recommended that you use PKG. Okay, so this is the standard interface to Termux, just a terminal. So you will have to learn how to use a terminal a little bit. Termux can also install graphics applications, but setting it up so you can see the applications in your mobile phone is a bit tricky, and for our example, it's really not needed. So first we have to do some updates. So we execute pkg update. Okay, so that Termux downloads the list of packages from its repository. Okay, now he says he needs to upgrade some packages. Okay, we press enter and let it do the upgrade. He's asking to substitute one of the configuration files. We reply yes, so that it's updated with the last configuration. Okay, and now we will execute package upgrade to, in case I think it's already done, but we will execute in case we need something to upgrade. Okay, so it's done. We have now a basic Linux system where we can install additional software. Okay, so another thing is that Termux doesn't have any permissions, special permissions. One interesting permission is to be able to access our shared storage system in an Android. Basically, the files we see from the regular Android applications. It can be done with Termux script that is called Termux setup storage. Okay, just by executing that command, writing the command and pressing enter, we will tell Termux to set up. So our device acts as tell us that Termux wants to access our regular storage, and that's it. Okay, now we can see that. Now, in this video, we are going to see how to use a Verilog compiler. So we are going to install it. pkg install, and the package is called iVerilog. It is the same name we have in Ubuntu, for example, and that's it. It's been just 3 seconds maybe. We have a Verilog simulator and compiler installed. It doesn't have any graphical interface. It's just the iVerilog command. Okay, it works from the command line. In case you are not familiar with the terminal, I will tell you just the basics, the very, very basics of using the terminal, just enough to be able to create our first project in Verilog. Okay, so now the very basic is just moving around in the terminal. When you're working in the terminal, you execute commands. For example, the clear command cleans the terminal. You are always working in some folder. You can see the folder you are working in with the pwd command, which stands for print working directory. And this is the home directory for your Termux. Okay. If you want to see what's in that directory, we have the command ls, that stands for list. We have a folder that is storage that Termux has linked to your Android storage area. So we are going to enter that folder. To enter one folder, we execute cd, that stands for change directory. When you write something in the terminal, the terminal is very intelligent, so you can write a few letters and then press the tab key if you're using a physical keyboard, or this symbol here. Okay, this is a small virtual keyboard that Termux has with some useful keys. So it will complete the name, and it makes working with the terminal much easier. So now we are in the storage folder. Inside that folder, we have links to some typical folders, and in the folder that is called shared is where we have all our regular Android folders and things that we can see from our device. If you want to go back to the Android interface, go to the home interface, and you can check with a file manager. Okay, all these folders that we have, okay, is what we can access from the terminal. Our terminal is still there, it's still working there, so we can move from Termux to regular Android. Okay, now we are going to if anytime we want to move to the parent folder, we are in shared folder, we wrote cd ... Okay, so we move to the parent folder. So now we are entering the shared folder again. We are going to make a directory to work with our Verilog files. The command is mkdir, make directory, and the name is Verilog. We enter that directory. Okay, so we are ready to start our first example. Now inside Verilog, I'll make still another directory for our example. We are going to design a simple voter circuit. We are in the Verilog folder. We need now to create a file. To create a file, we need a text editor. Termux comes with a simple text editor that's called Nano. Okay, Nano is also available in most Linux distributions. So if all you learn here will be useful if you move to a Linux system. And we are going to create our voter.v file, okay, with the description of our circuit. Now it's very simple to use because it works in the terminal. It depends on your device. Maybe the mouse is not, or the touch screen is not useful there, but you have the keys you may use to control the terminal. This means Control X, Control G, Control W, and so on. Okay, so this is our voter circuit, and our module will be called voter and has a few inputs. Input wire A, B, and C, and output wire Z. Okay, great. I'm not, I suppose you already know some Verilog. I'm not explaining the details here because it's intended to be not very long video. And for our description, we will use an assign. Basically, the voter circuit is a circuit that makes the output equal to 1 whenever 2 or more inputs are equal to 1. So it corresponds to a logic expression like this. Okay, so this is end module. Okay, so now we are going to save the file. We open the file. We wrote nano voter.v, so Nano automatically created the file for us. If we want to save our file, just press Ctrl O. If you don't have the control key in your virtual keyboard, you can press the key here, or if you are using a physical keyboard like I'm doing now, you can simply press Control O, I missed that, Control C to cancel. Okay, file name to write, voter.v, enter. Now it's saved now. In order to check that the file is correct, I must compile this Verilog code, okay? We don't really need to exit the editor to go back to the terminal, because if we swipe from the left side, here we have the Termux menu, and we can start a new session from here. So we have another terminal, terminal number 2, okay? We can have as many terminals as we wish. And the good thing is that we are working at the right folder. Okay, actually I have created my voter file outside the voter folder I created, but we can fix that later. So to compile my design, I execute iVerilog, which is the Verilog compiler, and just put the files I want to compile here and press enter. No, now I have a mistake in line number 5. There's something wrong there. So I move to the terminal where I'm running the editor, terminal number 1. And let's check line number 5. 3, 4, 5. Output wire. I put a semicolon here, okay, which doesn't go here. Okay, Nano TX editor has it's very simple, but it can be configured. If you press Ctrl G, you have here a configuration help here. So for example, there's some way to activate line numbers. Let me check if I find it. Command store remove. Okay, here it's meta n, which is the Alt K followed by n. So I Control X to close and Alt N. Okay, so it was line number 5. Now I save my file again, press enter. Okay, and I move to the terminal, to the other terminal, and just execute the command again. To execute the command again, you can use the cursor keys here, for example, the up arrow, and you can repeat any command you have previously typed in that terminal. So we repeat the command, and now we have no errors. Okay, so now we are going to edit our test bench. So let's go back to the editor. We are going to exit. Control X, and we are going to edit a test bench. Okay, actually we are going to use voter nano voter tv.p, and our module test. We are going to define some internal signals, rec A, B, and C, and wire Z for the output. I'm going to place an instance of my voter here and connect signals. Okay, I've placed my voter. Now I'm going to write my test bench code. I will have a process, an initial process where I will do all the simulation control. Okay, let's initialize our variables. A will be equal to 0, and we'll do everything in the same line. B is equal to 0. C 0. So my input signals, the input signals to my voter under test will start being 0. Then I will put some simulation control. We want to print some results. So I will, because we are working with the terminal, the most useful test benches are those that print to the terminal. We can generate waveforms, but we then need a program to show the waveforms. Normally with Icarus Verilog, we will use GTK Wave waveform viewer. It's also included with Termux, but because it's a graphical program, we will need to set up the graphical interface. If you want to try, just go to the Termux webpage and see how to do it. Okay, so we will just display our values B, C, and Z, and let's monitor. Let's print a line here, and then just monitor every change in those variables. Okay, we'll print all the variables in binary format. And we print A, B, C, and Z. Okay, if you want to generate waveforms, as I told you before, we will do something like dump file and dump bars and so on. Okay, but now we just will do that. And now after some time, we will just finish. After 100 nanoseconds, we'll just finish our simulation, and that's it. Okay, because we want to count nanoseconds, we have to include the time scale directive. 1 nanosecond, 1 picosecond, okay, which is also very standard. And module, okay, but before ending our module, we need to change the input signals A, B, and C. Well, I will use the most basic solution for that, which is to use an always process, and every some time, like 10 nanoseconds, we will simply use the input variables like a counter. Okay, so I combine the 3 variables and I just increment the combination of them. Okay, so this will start being 0, 0, 0, and then I will increment that, so they will go through all the possible values. Only you have to give time enough for the variables to take all the values. And okay, I think that's it. I will write my file, Control X, save buffer, yes, and oh, I'm leaving the I actually left the editor. Okay, no problem. Now let's change to the second terminal. I will now call iVerilog, and now I include my design and also my test bench. And I didn't make any mistake. That's not normal, okay? But I think it works. So when you do that, Icarus Verilog generates this file here, a.out, which is the compiled design in a file that can now be simulated. The simulator is called VVP, and just pass the compiled file and it will run the simulation, and here we go. Okay, we have our VVP.out and we are monitoring all the changes. This is a voter circuit, so if you see whenever 2 or more inputs are equal to 1, the output is equal to 1. We can check it's correct, and now we have our first Verilog simulation done. Okay, now let's fix things a little bit, and let's move all these files, the voter files, to the voter folder. To move files around, we have the mv command. So I put voter.v, voter tb.v, everything we want to move, and now we write the name of the folder, the destination folder, which is the voter. Okay. A.out is a temporal file, so we can remove it with rm a.out. Okay, now that's great. If I want to continue with my design, here I am in the other terminal. Okay, now I'll go into the voter folder where I have my files, and I can now edit the files. Actually, we can edit both files at the same time. Here we are. Okay, in Nano, and Nano now tells us that we have two files. We are editing file 1 of 2. Okay, if we want to move to the other file, we can do that with the Alt key and using the less than or greater than key, or the cursor keys, arrow keys. Okay, so we can press Alt and the arrow keys and move to one file or the other. So this way I can work on my files, write my code, okay, and then move to the other terminal, going into the voter folder and compile things and test. Okay. Okay, now this is finished for this basic tutorial, but before, I'd like to show you how you can continue if you like that idea of working with Verilog in your Android device. So probably next thing that you may find interesting, I will move to the editor terminal again, and I will leave the editor. Is you may try a more powerful editor. Termux has many software packages, and you may try another editor, which is Vim. Okay, VIM. VIM is a very special editor. It's a version of the traditional Unix VI editor, but much more powerful. But Vim is not for everyone, and it's not easy to learn because it requires some learning. The good thing is that you can be very productive when you use Vim. But don't try to execute Vim without knowing some thing about the editor. Okay, so instead of executing Vim the first time just like that, you will probably not know how to go out of the editor. You may try the Vim tutor program, which is Vim with a tutorial. It's about a 15 minutes tutorial that will tell you how to move around with the editor, okay, and how to exit the editor if you need. So you just read the tutorial, follow the instructions, and you will have everything you need to start editing files with Vim. Once you know something about Vim, the good thing is that with Vim you can edit in a much more powerful way. For example, Vim includes syntax highlighting. You can also get you can also have multiple windows inside Vim, and you can edit two files at the same time. You can use your mouse wheel, or your tablet screen to move around. Okay, you can select with your mouse. You can have a terminal inside Vim. So in that way, you will have everything you need to do your. You can change the size of the windows with the mouse. So you will have a real professional programming environment, even if you are inside the terminal. Okay, so Vim is a really powerful tool. Another thing that you may want to try is that if you want to learn Verilog, you can access my examples-based Verilog course, which is in Gitlab. So you go to gitlab.com, jjchico, Verilog course.v. Okay, and from there, you have an introduction here, and you have the Verilog folder here, and the course is based on practical examples, starting at the very beginning. So you go to one example of prime number detector, for example, and then you can see the code here, and the examples has detailed explanations of everything used in the example, so you can gradually learn Verilog. Actually, if you want to use it in your Android tablet, it is very easy to download. Let's go to the main folder. We can go here and we are going to download it as a zip file. Okay, it's already downloaded. So we don't need to uncompress it here. We can go directly to Termux. Okay. Then let's enter storage, downloads, and here you are, the file we have just downloaded, the Verilog course. We can unzip it from here because Termux already includes the unzip command. We enter the folder, the Verilog folder, and there we start with lesson 1, or we can move to another lesson like lesson 3, the primes number. Okay, and from here you can try that. Okay, when you master primes.p. Okay, let's open the test bench. Let's open a terminal and let's go with the examples. Okay, you just go here and then you can start reading the example, learning how to do different things. At the end of the test bench, you have detailed instructions on how to use every example with Icarus Verilog. Okay, you can use in your Android device or in your computer if you install Icarus Verilog in Windows systems, Mac, or Linux. Okay, and then you just check primes. For example, we are just going to use the default code. And you can see that we actually have our prime number detector. Let's give a little bit more room. Okay, we detect prime's number, hopefully. Okay, so that's all for this quick introduction to using Verilog in any Android device. So you now can learn Verilog digital circuit design whenever you carry your phone or tablet. Thank you.